Good everyone, here is Group 8 from SETK 4143 Chemical Product Design class, and today we are going to present our proposal with the title of Dehumidifier Design. Dehumidifier can be defined as an electrical air conditioning device that lowers and regulates the air's humidity at a comfortable level by extracting the water from the air. This is to ensure a good indoor air quality. From 2019 to 2025, the dehumidifier market is anticipated to expand at a CAGR of 5.4%, reaching $3.8 billion, and it is believed that the environment's humidity in Malaysia might cause a variety of health issues for the people. So, the dehumidifiers are therefore frequently utilized in the residential, commercial, and industrial sector in Malaysia. In addition, the demand for this dehumidifier is rising in places with the temperature below 30 degrees Celsius. From the market research, we finally determined to produce fresh air ventilation dehumidifier for house use purpose. Based on the market survey, the needs of product function, environmental, and safety are identified as in the table shown. All the needs are fulfilling the product attributes as listed. Next, a house of quality was developed to combine the technical and marketing experience. From here, the relationship between the customer and technical requirements are described by the correlation matrix in the blue color column and give the importance rating for the technical requirement. Besides, there is a column to show the capabilities of the competitor in fulfilling the customer preference. Among three, Delonkis Industry is determined as the best dehumidifier supplier, which is also the largest competitor for us. So, in order to develop a successful dehumidifier, the business model canvas is formulated with 9 building blocks consisting of key partners like build-up material supplier, franchisers, logistic company, and many more else. Then, key activities which involve the production and operation, marketing, and etc. And key resources such as the manpower, financial, and raw material. Then, value proposition, where the most important is to withdraw the moisture in the air efficiently. Then, customer relationship. For this, membership, monthly promotion, and free annual maintenance are good ways to respond to the customer's feedback. Then our selling channel will be online shop, retail shop, and through YouTube video ads by focusing on the customer segment like the people having allergies or asthma or the business that require dry condition. And lastly, the cost and revenue are also shown to illustrate the financial flow in our production.
Next is the product performance. The table shows the performance of the dehumidifier that designed by our group, which include the dehumidifying capacity, fresh air flow rate, exhaust air flow rate, and so on. Next is the configuration and key ingredients. First, the G4 pre-filter is act as the primary filter, which will filter out the coarse dust with the particle size greater than 10 micrometer, such as cement dust, textile fibers and hairs, and so on. And for the second stage is the F7 secondary filter, which will filter out the fine dust with the particle size from 1 to 10 micrometer, for example, all the bacteria, most smoke, most paint pigments, and oil fumes. And the third stage is the H13 HEPA filter, which will filter out the suspended particulates with the particle size of smaller than 1 micrometer, such as virus, carbon dust, radioactive suspended particulates, and so on. And next, for the fourth stage is the negative ion. The particles with size of between 0.3 to 0.5 micrometer will be extracted and removed. Due to the powerful absorption capability, microparticles in the air can be absorbed by the anions to remove dust and organisms. And lastly is the UV lamp. The UV radiation has higher efficiency for destroying and activating the virus. The UV jumbles up the DNA sequence, causing the virus to be incapable of reproduction. UV possesses no threat after it reacts to the virus.
The phenomenon that happens in dehumidifier is heat transfer. The key part of how every dehumidifier works is the refrigerant, which is a fluid used in all kinds of devices where heat transfer is required. The way refrigerant facilitates heat transfer is by undergoing a phase transition from liquid to gas and vice versa. This figure shows the air dehumidification process. Firstly, the compressor is the part of the dehumidifier that powers the heat exchange cycle. As the compressor runs, It pushes the refrigerant through the evaporator and condenser to facilitate the heat transfer process. The fan will draw the humid air into the dehumidifier via an air inlet. The dehumidifier uses the cold coils, which is the evaporator, to remove moisture from the air. In turn, it uses the condenser as the hot coils to reheat the moisture to room temperature. The same fan that absorbs the humid air into the dehumidifier will now propel the dry air out. The refrigerant flows in a closed tube where it encounters temperature changes but not volume changes. From the equation for an ideal gas, PV equals to nRT, it is evident that if the temperature changes, the pressure will also change, because everything else remains constant. Such a process is called an isochoric process, in which the refrigerant in gases stated is either compressed or expanded at constant volume. This figure shows the schematic of a dehumidifier with a counterflow. Based on the previous studies, the heat and mass transfer models of this type of dehumidifier can be expressed as follows. To meet the product performance in which the total heat exchange ability in the dehumidifier equals to 0.8 and the total mass exchange ability in the dehumidifier equals to 0.86, the specification of the dehumidifier are figured out based on the conditions given. First, by substituting the constant C1, C2 specific heat, temperature of air at inlet, temperature of air in equilibrium with the solution, and temperature of the refrigerant, the temperature of air at outlet is calculated, which is 18.8 degrees Celsius. Next, by substituting the value of constant S, C1, C2, the specific heat, humidity of air, refrigerant, and mass transfer process, NTU, the humidity ratio, and etc., the humidity ratio of air at outlet are obtained, which is 5.8 gram per kg. The enthalpy and temperature of liquid desiccant solution at outlet of the dehumidifier are 33.5 kJ per kg and 22.8 respectively by using the derived mathematical models.
So for the next part, which is the back 3D drawing of our selected configuration, after that, the fan will expel the air outside. This is the dimension of our dehumidifier designs. Take note that the L is length, W is width, and H height, D is the diameter. So for the material selection of our design, the fans will be using a plastic pilot, compressor will be using scroll compressor, condenser tube will be using copper with aluminum coil, refrigerant will be using R410A, the water tray will be using stainless steel, for the outer shell we will be using ABS, and lastly the color of our product which is black.
Now let's have a look at the economic analysis. This table below shows the cost of raw materials of dehumidifier as utilized and shown in the chapter 2. And therefore, since only raw materials are considered in the total price, the selling price of dehumidifier is estimated at least 200% of the price of the raw materials. Therefore, the selling price were calculated and estimated to be 170 ringgit. Next, the assumptions that we made will be annual advertising budget of 9,000 ringgit, net working capital of 220,000 ringgit, development cost of 220,000 ringgit, development time of 1 year, manufacturing equipment cost of 330,000 ringgit. And next we'll have a look at the IRR based on from the data summary from the project cash flow calculation. Therefore, we will get the annual sales selling price, annual advertising budget, manufacturing equipment cost, development time, development cost, net working capital, rent, manpower, R&D, total fixed cost, variable cost, bank interest, and tax rate.
To calculate investors' rate of return (IRR), we need to calculate the depreciation and book value using MSCRS tax basis depreciation for 5 years. So year 1, 2, and 3 is 20%, 32%, and 19.2%. Then we will calculate the depreciation and book value. So these are the values for the depreciation and book value. Next, project cash flow. We start with the year -1 because the development time is 1 year. So year -1, 0, 1, 2, and 3, and these are the values. So for the PCF, we can see that the year -1 and 0 is negative value, and then start from year 1, 2, and 3, it is positive cash flow and increasing the value. So the numbers in the red font indicate negative cash flow. Next, to calculate net present value NPV and IRR, we assume the discount rate is 20%, which is 0.2, and this is the formula for NPV, and we get the positive value for NPV, which is 308,667.59. Since the NPV exceeds management's expectation, so the project can continue. Then to calculate IRR, we assume the NPV equals to 0, and we solve it using the GoSeek in Excel and get 38.03%. Since IRR larger than the bank interest rate 6.38%, so the project is feasible and can continue. Then the payback period. This table is the summary of cumulative project cash flow. So we can see the payback period is located between year 1 and 2 because there is a sign change. And then we calculate using interpolation and get the payback period is 1.63 years. Based on graph of cumulative project cash flow as a function of time, we can see that the payback period falls between year 1 and 2 and it is close to 1.5, so the payback period of 1.63 years is justified. That's all from us. Thank you.